Hello everyone and welcome to my YouTube video. My name is Kitika Narnolia and today I'm going to explain about the topic different memory management techniques in operating systems. So now the question arises, what exactly is memory management? Memory management in an operating system handles the hierarchy of memory resources, ensuring that processes have sufficient memory to execute while optimizing the overall system performance. It involves various strategies for allocating physical and virtual memory, managing multiple processes, and handling memory errors. So, now we will move on to the memory management techniques. The first one is contiguous memory allocation. Contiguous memory allocation assigns a single contiguous section of memory to a process. It includes fixed partitioning and dynamic partitioning. Fixed partitioning divides memory into fixed size partitions. Each partition can accommodate exactly one process. The size of partitions can either be equal or different. It is simple to implement and manage. The other one is dynamic partitioning. Dynamic partitioning allocates memory based on the exact requirements of processes, leading to partitions of variable sizes. It reduces internal fragmentation, but it can cause external fragmentation. Now the next one is non-contiguous memory allocation. Non-contiguous memory allocation allows a process to occupy non-contiguous section of memory. This method is more flexible and can efficiently utilize memory space. It includes paging and segmentation. Paging divides both memory and processes into fixed size pages and frames. The process pages can be loaded into any available memory frames. Paging eliminates external fragmentation and allows easy management of memory, but it introduces overhead in maintaining page tables and can cause internal fragmentation. The other one is segmentation. It divides the memory into segments based on the logical divisions of a process, such as code, data, and stack. It provides a more logical way to manage memory, reflecting the structure of a process. But it's prone to external fragmentation and it requires complex memory management. Now we will move on to virtual memory. Virtual memory extends the physical memory onto a disk, allowing the execution of processes that may not fit entirely into physical memory. It uses both paging and segmentation techniques. Virtual memory includes demand paging and page replacement algorithms. Demand paging loads pages into memory only when they are needed. Hence, it reduces the initial load time and memory usage. Demand paging is efficient use of memory as only the required pages are loaded. But the page faults can degrade performance if they occur frequently. The next one is page replacement algorithms. Page replacement algorithms determines which pages to swap out when new pages are loaded. So the common algorithms include first in first out, which removes the oldest page, and the next one is least recently used. It removes the least recently accessed page. The last one is optimal. It removes the page that will not be used for the longest time and it requires future knowledge. Now we will further move on to swapping. Swapping moves entire processes between main memory and a backing store to free up memory for other processes. The one advantage of swapping can be that it enables better memory utilization by swapping inactive processes. And its disadvantages can be that it can cause significant performance overhead due to disk input and output operations. Now the next part is memory allocation techniques. It includes best fit, worst fit, and first fit. Best fit allocates the smallest available block that fits the request. It reduces wastage of large memory blocks, but it can lead to many small unusable memory fragments. The other one is worst fit. Worst fit allocates the largest available block. It reduces the chance of creating small fragments, but it often leaves large unusable gaps, leading to poor utilization. The third one is first fit. First fit allocates the first available block that is large enough. It is fast allocation, but it can cause fragmentation near the beginning of the memory. Now we will study about the memory management in modern operating systems. Modern OS like Windows, Linux and Mac OS implement advanced memory management techniques. Windows uses a combination of paging and segmentation with a focus on virtual memory, and it employs sophisticated algorithms to manage the paging file and uses a working set model to control the physical memory allocated to processes. Next one is macOS memory management. macOS employs a similar virtual memory strategy with demand paging and an emphasis on protecting process memory. It uses an object oriented approach with memory objects and maintains efficient memory usage through its dynamic memory allocator. So, here we conclude that memory management techniques in operating systems are critical for ensuring efficient and effective use of memory resources. From basic contiguous allocation methods to advanced memory systems, these techniques play a vital role in the performance and reliability of modern computing systems. Understanding these concepts is essential for anyone involved in system design, development, or administration. So I hope you understood this topic. Thank you so much for watching my video.